Yes, ma'am, please. Good morning. Now we can start. Shridevi, madam.
Hello, yes, sir.
Yeah, yes, ma'am.
Sir?
Please, now you can start.
Thank you, sir. A very auspicious morning to a distinguished chairperson, faculty members, researchers, and participants joining us from across the globe. We are delighted in welcoming you all to day 2 of International Seminar on Python and R Programming for Data Analytics and Scientific Computing, organized by Department of Mathematics, MOP Vaishnav College for Women, and MathTech Thinking Foundation. We hope you all had a very productive day 1. Today, we start our first session by diving into the twin pillars of modern data science: scientific, statistical computing, and data analytics. In the era driven by big data, the ability to transform raw numbers into actionable insights is paramount. While Python provides us incredible flexibility, R remains the undisputed champion for rigorous statistical analysis and data visualizations. This session will provide us how these tools empower us to solve complex scientific problems. To guide us through the technical session, we invite our chairperson for day, Dr. B. Bhuvaneshwari, Assistant Professor, Department of Mathematics, MOP Vaishnav College for Women, to lead forward in introducing the resource person for this session. Over to you, ma'am.
Good morning, everyone. It's my pleasure to introduce our distinguished speaker, Dr. Harmanpreet Singh Kapoor, of this session. He is a renowned statistician, educator, and researcher serving as an assistant professor in the Department of Mathematics and Statistics, School of Basic Science, Central University of Punjab, Bath, India. He obtained his PhD in statistics from Punjab University, Chandigarh, secured a gold medal in MSc Statistics, and has successfully qualified several actuarial examinations conducted by the Institute of Actuaries of India. Over the years, Sir has established himself as a leading researcher in actuarial statistics, statistical modeling, biostatistics, survival analysis, reliability theory, machine learning, data analytics. His research endeavors focus on leveraging statistical and analytic frameworks to address his contemporary challenges in insurance, healthcare, environmental science, economics, and risk evaluations. Through the integration of classical statistical principles with emerging data-driven methodology, has contributed to meaningful advancements that enhance analytical insights and support effective decision making. Apart from his research accomplishments, he has remained actively involved in academic leadership, professional engagement, and knowledge dissemination. He has published extensively in reputed journals and has been awarded research grants from prominent funding bodies, including DST SERV, at ICMR, ICSSR. He is widely invited as a keynote speaker in various international national conferences, workshop, faculty development programs, and training sessions. A dedicated mentor and academic guide, he is a patient about encouraging innovation, strengthening research capabilities, and cultivating analytical excellence among scholars. His continued contribution are helping shape the future of actuarial science, data analytics, and risk studies, while fostering a strong culture of research and lifelong learning. We are eager to benefit from your knowledge and experience in this insightful session. Now it's my privilege to invite our esteemed speaker to deliver his expert talk on statistical computing and data analytics. Over to you, sir.
Okay, thank you, ma'am. Thank you, Dr. Bhuvaneshwari. Can you hear me?
Yes, sir.
Okay, so thank you, Shridevi, ma'am, for a very nice introduction. So although this is a very lengthy introduction that you have given to me, it is better to summarize in few lines that I am working as an assistant professor. That is enough. Because people are more concerned about that, how they are going to learn new things. They are not going to, you can say, go through my profile. They can go through my profile after the session, right?
Okay.
Okay, so it is better that we're going to start with today's session. So before going to start today's session, I have few questions that how many students are there that they are very that means they are learning this software first time. All of them are that means students they are doing R programming first time, or someone are there that they have done it earlier also. Can you just write your answers in chat box also? That is easy for me also to understand that. I want to know that what type of audience we have. So based upon that, we can start our today's session. So although you have covered the basic of R programming yesterday, so today what I'm going to do is that I'm going to tell you that how we are going to do the testing of hypothesis. That is very important topic in nowadays in every research area. So if you're going to do any research, you have to develop some objectives, and based upon the objectives, you have to test whether that objective is true or false. My voice is clear, right? Okay. So now after that, we have to do the testing whether the objective that you have framed that is correct or incorrect, right? So now what we are going to cover today that I'm trying to first give you basics of statistics that, and then we will do the programming. That means whatever the things theoretically I will teach you, then I will tell you that how you can do that thing in R programming, right? So I have a lot of messages from a lot of participants. They are using R programming first time. That's a very good thing. That now I have further one question for you, that why you want to learn R programming, because nowadays you have a lot of free softwares available, and although R is also free software, but there are a lot of softwares, there are a lot of tools available that do not need programming. Then why you want to do programming? Because this is customized one. Can anybody answer my question? My question was that why you want to learn coding, or why you want to learn R programming, although you have a lot of other tools available in the market. Why you want to learn R programming? So if you want to do some research in future, if you want to work in some MNC, if you want to work independently as freelancer, right? So there must be some objective in your mind that you want to do this for some particular task. So I got one response that to use it in data analysis and research. That is very good answer. That means I'm expecting this thing that because without any objective, if you're learning something, that means if I teach you R programming, I teach you Python in 1 or 2 days, right? And if you do not want to pursue that thing in future, then it is just like a passage of time, right? So when you are learning something, you have to touch. That means you have to consistently work on that area, so that will help you in future, right? So now, so yesterday you have done, I think, how to install R programming, how to install R software, how to install R Studio. Then you also have done that what is console, what is compiler, what is environment window, right? So you already have covered data frames, vectors. I think you already have covered logical expressions also. So today I'm going to start with a topic that is maybe you're not very much familiar. If you're familiar, just let me know. Then I will skip that topic. So in statistics, hello, does anyone has any question, query? Okay. So now I think my okay. Let me share my screen. I think my screen is not visible. So my screen is visible now. Okay. So now you can see that. So in statistics, I think most of you have heard about that there are two terms. One is called descriptive and second one is called inferential. So if you're familiar with me, then we can directly go to programming. But I want to know that anyone from the audience or anyone who think that someone has known about something about this, they can first give me the difference between these two terminologies and what these two branches represents. Have you heard about the term descriptive statistics and inferential statistics? Hello. Okay.
Hello.
Yes, yes. Continue, please.
Yeah, for descriptive statistics, am I
Mhm.
audible?
Yes, yes.
Yeah. For descriptive statistics, we are trying to describe the data that we already have. So we are
Okay.
trying to tell the story from how the data is seen at the moment.
Okay. Very good.
For inferential statistics, we are trying to make predictions or trying to understand why some things are as they are in the data. For example, why maybe more females are have more cars than the males. So that's inferential statistics.
Okay. You are let me try to complete the things that you want to say. So in the descriptive statistics, let us suppose we how many participants we have. I think we have 33 participants, for example, at this moment, right? So if we are talking about only these participants at this moment, and we want to just summarize the things that if we have the complete information about them, that what is the you can say age, sex, and other information that we have, then it comes under descriptive statistics, right? Are you with me? Okay. So now inferential statistics means that we have larger population, and but we are not able to assess the whole population. So what we do, we take some samples. Okay. Now from the samples, what we have to do, we have to make an inference for the whole population. Okay, so based upon the sample observation, if you're going to infer, that means infer about the whole population, that comes under inferential statistics. So there are various methods in inferential statistics, maybe you have heard about. So I am going to tell about some of them because in this course, in this today's talk, I can't cover each and everything. So I'm just trying to give you the glimpse of each section. Then we directly go to the programming, right? So in the inferential statistics, maybe you have heard about estimation. Okay, the second one is called testing of hypothesis. The task that is assigned to me, that I have to cover this topic, testing of hypothesis. So before going to discuss that, I have to make some base that why we are discussing this topic. So in the estimation, what we are discussing that in the estimation, this is my whole population, and this population means doesn't mean that we're talking about only human beings. We can talk about any object in which we are interested, and it is very difficult to collect the information from each object. So what we do, we take some samples, and from the samples we try to make an inference that represent the whole population. So now in the estimation, we have two methods. Either we take one sample at a time and we draw a inference. This is called point estimation. I'm going to give one example that will be more easy for you. The second one is called confidence interval. For example, let us suppose if I'm interested in that how many students, that means how much expenditure students are doing on average in a month, right? So I have collected students from a particular university or from one state. So it is not easy for me to collect information from each individual student that belongs to one state or one university. So what I do is I will take some samples and I give some value that I have collected 500 of the questions. And total population maybe consists of 1 lakh students, 10 lakh. I do not have that is my assumption at this moment, right? So I have collected 500 observations. So now what is the best method do you think that can be used to take inference from the students? My objective was I want to know that what is the monthly expenditure of student on average. Anyone, any guesses from the audience? So I want to keep discussing with me so that I got to know that how much you are able to understand. So it is better you either you write your message on the chat, or either you directly you can say unmute yourself and discuss. My question was clear. Should I repeat again? That in a state we have 10 lakh students and have collected information from 500. The way that how I have collected, that is not our part of a discussion, that is a separate study. So I am assuming that I have information regarding 500 students. Now from these 500 students, I have to make inference. I have to tell that what is the average expenditure that student they are doing on monthly basis for this 10 lakh students, right? So any guesses from the audience? I will help you out, do not worry. You can write on, you can write your message here also, so I can respond directly. My question is clear. Should I repeat again? So from the 500 students, how you're going to make an inference? That means someone has used a term prediction. That is not the exact term, because prediction is something different. So I'm using a term inference. That means based on sample observation, this 500 observation, how I can generalize my study, it means conclusion for the 10 lakh persons. Paired, I'm not talking about the testing part at this moment. I'm talking about that which method is helpful. Yeah, averaging is a good thing. So this is one of the method. For example, what ma'am has suggested that we collected information from 500 observations, 500 students, and we note down their values. That means how much money they are spending on monthly basis, and we can say that if, let us suppose, this value is coming as we can say 5,000 or 8,000. 8,000 is more relevant. So 8,000 I'm assuming. So it means that I can say that mostly on average basis I can say that 10 lakh students, they are spending 8,000 on monthly basis. But now, so my question is that if I change my sample, so the possibility is that my value got changed. Are you agree with me? So I have collected 500 students. So if I collect next 500 students, it may possible that some of students may be got repeated, some of students may be new. So second time I will not get value 8,000. So it may be different from 8,000, it can be less than 8,000, it can be more than 8,000. Agree with me? So what we do, we construct a method that is for confidence interval. Confidence interval means we try to construct a lower and upper limit, and based upon this lower and upper limit, we can say that with some confidence, either 95% confidence or either 90% confidence, we can say that our mean expenditure value lie in this range. Right? This is the technique that we use to opt in estimation. Now coming to testing of hypothesis. I think this idea is clear. Should I repeat again? In the confidence interval, what I can say that I assume that 5,400 is my lower limit and 10,000 is my upper limit. So I can say that with 95% confidence that I can quote that this in this range, the 95% with 95% confidence that average expenditure of students lie in this range. Okay, this point is clear. Now coming to the next topic, that is called testing of hypothesis. Testing of hypothesis is also very wide range. That means here we have a lot of techniques. So here, what we are going to cover. So in spite of collecting directly information from the sample and get inference from the sample, what I do is I give statement from my side. So I can state that I have given a value and I quote that this value will represent the whole population. Should I repeat again? I'm going to state that 7,500 is a monthly expenditure of students. Okay, that comes under a particular population, this population P. And now I have to verify that this statement that I have given from my side, whether this statement is true or false. So whatever statement I am giving from my side, that is called null hypothesis. Null hypothesis. Okay. So here we are using a terminology testing of mean. So I use a term that I'm giving a mean value on average that monthly expenditure of students. Though that means they are staying in a particular state, they are spending 7,500 rupees on average in a month. So now there must be some question in your mind that what happened if this statement is not true. For that, we will consider another possibility that is called alternative hypothesis. Alternative means that statement that is different from the null hypothesis, opposite of null hypothesis. So what we can say that if mean expenditure of student is, that means that is my assumption, that if it is equal to 7,500, that is not valid, right? Then alternative one is that it should be not equal to, or it can be greater than, or it can be less than. There can be only three possibilities, right? Okay, so now when we discuss such type of null hypothesis and alternative hypothesis, what we do, we take sample again. We have collected a sample of size 500 from the students, and now we will implement some tool that is called test statistics. And to make it very short for you, easy for you, from the test statistics, we got some value that is called p-value. Okay, so if the p-value is coming to be less than 0.05, okay, I'm skipping some of the mathematical calculation here. I'm directly taking you to a concept that is widely used in biosciences and other non-mathematical branches. They use directly consider p-value. And if we have p-value less than 0.05, so we conclude that whatever hypothesis that we have framed, that is incorrect. Should I repeat again? So we collected sample and we put that sample in some mathematical formula that is called test statistics, statistic. And after that, we got some p-value. And if p-value is less than 0.05, we reject our null hypothesis. Okay, reject our null hypothesis. That means this statement is that we have given, that is my assumption, that is incorrect. So I have to go to the other alternative one. So at a time, I can consider only one alternative at a time. So either I take one this pair, that is mu is equal to 7,500, mu is not equal to 7,500. Second possibility is that I have taken mu is equal to 7,500 and mu is greater than or less than, right? So now you can see that here what we have to do is, I'm audible, right? So what we have to do is we have to see that under which situation, which test we have to use. So we have to understand that. So when we have only one group means one sample that we have discussed above, that we want to see that what is the monthly expenditure of students. Okay, so that is my one group. So in a similar manner, if I take two states or two colleges or two universities, so I want to test that what is the mean expenditure. Hello, can you hear me?
Sir, we can hear you.
Okay. Okay, fine. Thank you. So someone has discussed me random sampling. That is a topic of sampling theory. So I'm not going to discuss that. Using an estimator, maybe an average. Very good. So now you can see that two states or two cities or two districts, two colleges. So it means we have, and we want to know that whether the mean expenditure of one state is equal to the mean expenditure of second state students or not. So in that case, we assume a hypothesis that mean of first state or first city or first college, whatever thing you want to keep in your mind, that is same equal to mean expenditure of second state, second university, and so on. So here we are assuming that our null hypothesis that we want to test the equality of mean expenditure of one state with another one university with another one college with another one. So in that we have two groups. The first group is here, the second group is here, and that thing is called testing of two group problem, testing of hypothesis of two groups. Right? And similarly, we have alternatives. We know that alternative is the opposite of this equality symbol. So we have not equal to the first possibilities that the mean expenditure of first state is not equal to mean expenditure of second state and so on. and that is greater than less than. So I'm not spending a lot of time. I'm just trying to give you the glimpse because these things are essential when we do the coding part. Okay, so what we have covered till now, should I repeat again? So first we have discussed the topic of testing of hypothesis. In the testing of hypothesis, we first give a statement from our side. That statement is called null hypothesis. And in the null hypothesis, we put value equal to, because we are saying that the value that I have given, whether that value is true or not. So alternative one is opposite of this thing. So either we take a possibility of mu is not equal to, or either we take greater than or less than. So these will be three combinations. The first combination will be this one, the second will be this one, and third will be this one. You can pick any one combination at a time, okay, based upon your objective. And after that, we conclude from the p-value. If the p-value is less than 0.05, we are going to reject the null hypothesis. The p-value is greater than 0.05, we do not reject the null hypothesis. It means that we are going to say that whatever null hypothesis that we have framed, that is correct, right? Now we have discussed that the above problem, we have only taken one group because we have picked only one state, one college, one university, and we are testing the mean of value of one group with some constant value. And in the same manner, we can compare the value of two groups in which we can take mean value of one state, mean value of second state, and we want to test the equality of the mean value. Okay. And whatever the things that I'm discussing with you, that comes under parametric. Although that is not required to discuss here, because we are not talking about what is the differentiation between parametric and non-parametric. But while coding, I will tell you the meaning of parametric and non-parametric testing. Okay. So here we can say that we are taking alternative one as not equal to, greater than, less than. So here not equal to means the mean of first state is not equal to the mean of second state. Greater than is mean of first state is greater than mean of second state, and less than third possibility. So again, we have to take some sample. Now we have to take two samples. The first sample is taken from the first group. Okay, it can be 250 units. It can be more than 250 units. Okay, I'm just giving you a brief idea, not very depth analysis, that how we are going to decide this sample size N1 and N2. Okay, but after that, we will put these values in test statistics, a mathematical tool, and we got some p-value. Again, if the p-value is coming less than 0.05, we are going to say that our null hypothesis is incorrect. We are going to reject the null hypothesis. Otherwise, we are going to accept that. So now coming directly to the topic, we will take one example at a time that will help you to understand that thing. So how to cover that? Okay, so I have prepared this lectures for you, although I try my best to incorporate each and everything here, but if still something is left, so although you can mail me later on also. So here I already have discussed with you that we are dealing with testing hypothesis part, right? I think I should have to write down on this, otherwise it will be easy for you. So what we are going to cover in today's session? We are going to cover testing of mean. So in literature, when we are going to test for mean for one sample problem, so generally we assume that for large sample size, the data set is coming from normal distribution. How many of you are aware about term normal distribution, symmetric data? Then I will, if someone is not aware about it, then I will explain it. Can you hear me? Okay. Hello.
Yes, sir, we can hear you.
Okay. Okay. So in the testing of hypothesis, we need an assumption that either data set is coming from normal distribution or not from normal distribution. If it is not coming from normal distribution, then the test statistics will be different. And if it is coming from normal distribution, then the test statistics will be different, right? So generally we assume that for large data set, it follows normal distribution, and it will be a bell-shaped type of curve, right? Bell-shaped type of curve will be such like of this one, right? So now for the testing of mean of one group, that means we are assuming a null hypothesis. Notation is null hypothesis, and I use a notation mu for mean, and I'm saying that some constant value mu naught, that is my constant value. It can be 1200, it can be 7500, and so on. That is based upon your objective you have to choose. Now, how to do that further? Okay, so alternative one is can be not equal to, greater than, or less than. Okay. In literature, maybe some of you have heard about that although the data set is coming from normal distribution. Normal distribution has two parameters. One is called mu and sigma scale. Maybe you have heard about somewhere. So this is called mean parameter. This is called variance parameter. So if from the population, I am again emphasize, from the population, you have some idea, or you have some value of variance of population. Okay, it is given to you as 3 or 3 point something. Then you have to go with the jet test for the testing of mean of one group. I'm again going to repeat, for the testing of mean of one sample problem, where we are saying that the mean of first one group is equal to some constant value, and our data set is coming from normal distribution, and there are two parameters. One is called mean, second one is variance sigma square, and we are testing for the mean, and the second parameter sigma square, that is not known to us, or that is known to us. Then we are going to use a test that is called jet test. If the parameter sigma square is not known to us, okay, then we have to implement test that is called t-test, and the mathematical expression of t-test is given here, although it is not required for everyone to understand the mathematical expression, but one has to only recall that one has to check these only two conditions for one sample problem, that the mean is, we are doing testing for mean, and second one is sigma square is not known to us in advance. Then we are going to implement t-test. Okay, let us suppose one example I have kept it for you. We test whether the average monthly sales revenue differs from the target value. Okay, so let us go take an example of a company, and they have some, they are observing the monthly sales values, right? And their target value is given as 100. Okay, that is your mu naught that I already have explained to you. And they want to know that whether the company is able to achieve this target value or not. So you can see that how many observations we have taken here, 10 observations, right? So they have collected the information for 10 months, and they want to know that whether they are able to achieve the target value or not. And I'm assuming that this data set for normal distribution, although data set is very small. So for an assumption, I'm making that this data set is follow bell-shaped type of curve. This is my assumption here. And I want to do testing of mean of one sample problem. So now here you can, how many of you have done concatenate yesterday? How to write down this thing? If someone has covered this, otherwise I will type it. Concatenation, how to write down a vector. Yesterday, have you covered this or not? Okay, for your understanding, let me tell you. So whenever I'm using this syntax, either I can use the syntax or either I can use the syntax. Both have the same meaning. Okay, C is the terminology that is used to create a vector. Okay, and whenever I want to input observation, I have to segregate that observation by comma. So here you can see that. So 105 is the first value, comma 98 second value, and so on. So all these vectors, all these values comes stored in a vector and in a variable named sales, right? And I am using a syntax t.test for testing of one sample problem, and I want to use this t-test because I have no information regarding the variance of the population. Variance of the population means that company has only values of the average sales. They do not know the variability. And why we are implementing test? Because a company has, you can say, sales for 100 years also, 10 years also, 1 year also, 2 years also. In future, they also have to do some sales, but they only want they have only information for few months, and from the few months they want to know that whether they're able to achieve the target or not. Okay, so the syntax is t.test, right? Then I have to put my variable name sales, then mean value that I want to verify. That means my sales value is achieving the target value or not, 100 or not. And when I execute this code in our programming, okay, so what type of output I will get? You have to see here. I will explain to you. So we got p value. And can you tell me that the p value is less than 0.05 or more than 0.05? Anyone from the audience?
It is less than
Yeah.
0.05.
So it is, what does it mean?
It means we reject the null hypothesis.
So what is my null hypothesis? That average monthly sales of a company, right, that is equal to 100, right? That is not valid. So we can conclude based upon the sample that monthly sales is different from 100. I do not know what is a monthly sale on average. Okay, because from this you can say on average I got to know that the mean is coming something different from 100. That I got to know, but I'm very much sure from this testing hypothesis that it is different from 100 now. Okay, if you want to study further that what is the you can say actual value, that you can only take from a sample observation, right? For this only 10 observation, but one is not able to get the exact value. One can only provide you the confidence interval. From the confidence interval, you can see that the lowest value is 101.7541 and the highest value is 112.6459. So here we can only say with 95% confidence that this term is very important. 95% confidence that the true mean value, that is average monthly sale, okay, of a company lie in this range. So it starts from 101.7541 and 112.6459, right? And the mean of this above sample is coming as 107.2. So on average, it's different from 100. So we're going to reject the null hypothesis. But we conclude here that the mean expenditure, mean sales of a company, that is different from 100. Are you able to understand this point? And I think you are able to understand that how one can use t-test from one sample problem. Okay. So now I'm going to take it further. So now I will take two companies. Okay. Or you can say two branches of the same company, and I want to compare that whether they are going to give me the same values or different values. So we can compare the productivity of each branch. So here you can see that I have stored, create two vectors. Again, to create a vector, we use a function that is called concatenate, and we store the values here and we differentiate each value by comma, right? And we store the value in branch A and second branch. Okay, hope this is clear. And again, we are going to use this method that is called t.test. Again, I'm going to emphasize here that for testing of mean of two groups, mu1 is equal to mu2, that is mean of first branch, mean value of second branch. Alternative one can be, you can assume that mu1 is not equal to mu2, mu1 greater than mu2, mu1 is less than mu2. I have example of that, how we can assume equal to, not equal to, greater than, less than. So here you can see that alternative hypothesis assumes two difference in mean is not equal to 0. So what does it mean? That if you take mu1 minus mu2, that is not equal to 0, mu1 minus mu2 greater than 0, mu1 minus mu2 less than 0, right? Hope this point is clear. So what we are trying to do, we have this information that we have two groups or two branches, you can say, and we want to test the mean of these two branches. And what else information we need, that each data set is coming from normal distribution. This is my assumption. And we already have discussed there are two parameters in normal distribution. So the first parameter is mu1, second parameter is sigma 1 square for the first group. Second group has the same parameter mu2, sigma 2 square. And we are going to test that this parameter mu1 and mu2 is equal to mu1 is equal to mu2. This is the thing that we are doing. But here we also have this criteria that whether the sigma 1 square is known to us or not. Whether the variance of one group is known to us or not. So this is our requirement. So if they are not known to us, okay, they are not known to us, then we are going to implement that T dot test. Okay, and this test is called two sample T test, or you can say independent sample T test. Okay, so here again we have to implement the function that is called T dot test, u that function T dot test, and we have to store the first variable name branch A in which we have stored the values of first branch as a vector, branch B. Now this is another requirement. Variance dot equal dot is equal to true. So what is this thing? Let me tell you. So under this testing of two sample testing problem, so we have this requirement that sigma 1 square, sigma 2 square, if they are not known to us, then we're going to implement T dot test, right? But we also need this assumption that they should be equal, although they are not known to us, but they should be equal, right? I think this point is clear. If they are not equal, for example, then we are not going to implement T dot test. Then we have to use another test that is called Welch T test. I will tell you that example again further. What is Welch T test and how to implement that? So for the time being, you have to keep this thing in mind that for testing of two sample mean, we need that this data set is coming from normal distribution. Further, sigma 1 square and sigma 2 square, they are known to us or unknown to us. If they are known to us, then we have to implement a test that is called jet test. Okay, although we are not covering that thing at this moment, but I'm going to tell you that, and generally they are not known to us in real life. So that's why we are going to implement T dot test. And further, we have to verify that or assume that the variability of these two groups, sigma 1 square or sigma 2 square, they should be equal. Then T test will be a good one. Otherwise, we have to use a test that is called Welch T test, right? Now, after implementing this code, what we got, let me tell you. So when we type this function T dot test and we call these variables branch A, comma branch B, comma variance dot equal is equal to true. So we are assuming that sigma 1 square and sigma 2 square, they are not known to us, but they are equal. Okay. So after executing the function, what we got the p value. Okay. From the p value, now can anybody explain me what we conclude? Okay, one question I got. So T dot test is generally is there, right? In the R programming, you can cross check it. Otherwise, the library, I will tell you. It is already inbuilt function. Ravi Shankar V, right? So my question was that from the p value, what we conclude now. And if someone is not able to understand the syntax, because I'm not very much sure that how much we have covered till yesterday. So if someone is not aware about vector creation, concatenate, how to write a function, okay, one can ask me. So I can explain it more. I have the R console also open. That is not an issue. That means I have prepared this file from R programming. So if I got time, that means I will have time, then I will explain to you how to create this file using R Markdown. But let me first focus on the topic. Okay, very good. So it is coming less than 0.05. So it means that we are going to reject the null hypothesis. So it is better to write, okay, say, quote the thing in statistical term. So when this value is less than 0.05, so we are going to say that this null hypothesis that we have assumed, okay, that is not, sorry, this one, that null hypothesis that we have assumed, that is not valid. So we are going to reject this null hypothesis. So it means that now whatever the alternative one, so here we have assumed that alternative hypothesis as not equal to, so this hypothesis correct one. Okay. So now further, I will tell you that how one can create these two alternative hypotheses, greater than or less than. I have example kept it for you. Okay. So now what we conclude here that from the 95% confidence interval, that mu1 minus mu2 is coming as 3.23 and 9.051. So from this confidence interval, what you will conclude? Can anybody give me some guesses? There are two branches of a company and they are giving you their, you can say, sales value or some other values. So the value is mean productivity. So these values represent the mean productivity value of two companies, two branches of a company, right? And we got the confidence interval as 3.23407 or 9.051644. So one thing you have to keep in mind that in statistics or in any branch, that means you want to work in future. Okay, coding can be done in one line code, right? The main thing that one has to focus on interpretation. Are you agree with me? Nowadays, chat GPT is there, softwares are there, right? So the main thing is that how you're going to infer the information from the output. That is more important. How you're going to correlate the things, that is more important. Tools are there. Tools can, that means tools are like a machine gun. You can use, everyone can use that. But the person that can use the guns at the appropriate, means to shot on a particular location, right? That is called a skilled person. So now the thing is that can anybody answer me that from this 95% confident interval, what do you conclude?
We can say that on average, the two branches have a difference in productivity of between 3.23 to 9.051 on average.
Okay, so let me make it clear. So you can see that all the values of confident interval, they are coming positive. Agree with me? Hello? You can respond me
Yes.
on chat also. So what does it mean? It means that the branch has more productivity as compared to branch B. How one can verify that? One can verify from here also. So you can see that the average mean productivity of branch A is 49 and the average mean productivity of branch B is 43. So one can easily see that the branch A is more productive as compared to branch B. So when we construct the confidence interval from mu1 minus mu2, so if mu1 is higher, then only we are getting positive values. Are you able to understand my logic? Right. So it means that you can conclude that directly here that branch A is more productive as compared to branch B. Now further company can think about that what is the reason behind that branch B is not productive well as compared to branch A. So they can explore, they can verify the things. So this is the main objective of conducting this testing. It is not just providing you the output and then make a file and then shut it down, right? So it is basically used to search further that what are the possibilities, reason behind having difference in the values. So this is the task of the other members of the company, but our main objective is that we have to make them aware that this thing is doing something good or bad, and we have to aware them. Now, so there is one further testing criteria that is called peer t-test. Some of you have mentioned the name of peer t-test earlier also, but let me make it explain it further because some of you are not aware about the terminology. So let us suppose there are some students, they have enrolled in this workshop, right? Although some of you are not aware about R programming earlier, so I'm assuming that some students they are using this R and Python first time, and they have enrolled themselves in this workshop. So I have noted down their skills, right, before enrolling in this workshop, and I have noted down their skills after enrolling in this after completion of this workshop, right? So now I'm assigning the performance by the mean value. That means average score that I have collected prior to this enrollment and at the completion of this workshop. So I have both the values. So here what we are doing, we are observing the information from same person, but at the two different time periods, right? Are you able to understand my logic? So I am saying that this is the stage before enrolling, before having this having the sessions or enrolling at the enrollment time period, and this one is after the completion of the workshop. So here you can see that. So I want to observe the mean performance, the mean difference in the performance. So this terminology can be covered as a paired data. Paired data. Paired means where the respondents are same, but we have noted down the values at different time periods. So that data set is called paired data. In the previous examples, we have two different data sets. Two different means the first group is first group is different from the second group. There is no direct connection between these two groups. When the observations are connected because the respondents are same, but we have noted the values at different time period, then it's called paired data. And for the testing of mean of this paired data, then we are going to implement test that is called pair t-test. For example, here you can see that this is the value, or you can say scores of students, okay, that that have been noted before taking a training. Okay, you can say these are the scores of employees that they have noted down before taking a training, and these are the scores of employees they have noted down after taking the training. So now we have to test that after attending the training, whether there's any improvement in the performance of the employees or not. So we are again going to assume that this data set is coming from normal distribution, and variability of this data set is not known to us, population is not known to us. So we are going to test a test that is called t-dot test. T-dot test. So you can say that the same test we have used for independent t-test, but the difference comes here. Paired. So we have to write down a term paired because we have to give an instruction to our programming that this data set is coming from paired data, and this is true. And one thing you have to keep in mind that somehow you do not write this thing. For example, you write down this thing before, after, okay, and you close the bracket. So it assumes automatically that the data set is independent. So to tell our programming that this data set is paired one, so what we have to do is we have to mention this thing paired is equal to t or true. Both have the same meaning, right? So now R got to know that this data set is paired one. So now he has to use pair t-test over this data. Okay. So now you can see that the output is coming as paired t-test. And here we are again getting the p-value that is very much small. And from this, we can got to know that there is a difference in the mean performance of the employees after attending the training. Okay. And one can also see the confidence interval. So that is coming negative. So you can see that after attending the training program, although you can see that this is IQ or this is the test they have passed, for example, and most of the values are higher than the previous values, right? So you can see that the confidence level is coming negative because this mu2 part is higher than mu1. And here we are providing the confidence level for mu1 minus mu2. Okay. And the mean difference is coming as -6. So it means that the mean of mu2 is higher than mu1 by 6. Well, sorry. Till this stage, any question from the audience? Any question? Because the next thing that I'm going to discuss with you, that is different from these three methods. So till now, let me revise the things. What we have covered till now, we have covered one group problem in which we have done the testing of mu1 is equal to mu. We have done two independent group problem in which we have done testing of mean of two groups. The third one is pair data, in which we have done testing of before and after. So I have written null hypothesis in all the cases. Alternative one can be mu1 not equal to mu0. Here mu1 not equal to mu2. Here mu b minus mu a is not equal to 0. So till this stage, any doubt, any question from the audience? Okay, so there is no any question from the audience. Should I proceed further? Yes. So now, as we already have discussed that for implementation of t dot test, so what we need this assumption that we are doing testing for mean. Data set is coming from normal distribution. The third assumption is that variance of two groups, t dot test for two sample problem, two independent. So variance of these two groups should be equal. So how to test that the variance of these the population is equal, although we do not have the complete information for the population, but we have only information from the sample, right? So how to make this assumption? So to test this thing, we are going to use a test that is called variance testing. Okay, variance dot test. There are various methods are available in the literature. So you can start with this method. Any question from the audience? Okay. So here you can see that you can note down, you can take the values of the data, and we are now doing the test of variance. Okay, so we use a function that is called var dot test. So earlier we have used a function t dot test. So we have replaced t with var dot test, the same syntax, right? And after getting the output, so we have to conclude that the p value is coming to be greater than 0.05. So what is our null hypothesis in this case? In the null hypothesis, we have assumed that sigma 1 square is equal to sigma 2 square, and alternative one is sigma 1 square is not equal to sigma 2 square or greater than less than. So but here we are getting p values greater than 0.05. So it means this null hypothesis that we have assumed, that is correct one, and that is a requirement to implement the t dot test, because we need this assumption to be true. So if this assumption is true, then we are going to implement t dot test successfully. Otherwise, what will happen? The conclusion we got, although you can implement t dot test, but the inference that you will got, that you will get from here, that is not correct one, right? So here you can also see that the confidence interval. So whenever null hypothesis got true, that means when the null hypothesis will be true, right? So you have to keep this thing in mind, that your confidence interval must hold 0 value. So here you can say that it is close to 0, not exactly 0, but it consists of 0 value, right? Any question till now? Then only I will start a new test that is called goodness of fit. Because I am not in hurry, I want that all of you, they are new to statistics, they are new to testing of hypothesis, they must understand the logic that what we are doing and why we are doing. I'm not in hurry to cover each and every method. My main objective is to cover the test that at least you know and can implement yourself in future. Okay, should I continue further? So the next method is called goodness of fit. How many of you have heard about term goodness of fit before? Tell me, otherwise I will explain to you. Okay, let me give you a brief of idea. So let us suppose, okay, Harvey, can you explain a little bit about goodness of fit method? And how many of you have done this thing before? That means all the programming you are doing first time, but have you done this testing of hypothesis topic before or not? Okay, let me explain. Don't worry. Okay, so now, for example, in some data set is given to you. So for example, I'm saying this as consists of some observations like this one, 50, 30, 20, and the length is very large. Although I am taking very small observation here, and I want to test that this data set is coming, you can say, is equally distributed. Some observations are high or not. I want to test that. So what I do is I'm going to implement a method that is called goodness of fit test, and I will say that if the data set is coming from normal distribution, data set is coming from any particular format like a constant value or not. So I will use this method goodness of fit test to test that. So here you can see that observed we have three values 50, 30, and 20. They are not equal, right? So what we are doing, we are saying that for a particular problem, so 40% value come from the first unit, 35% value come from the second unit, and 25% is coming from the third unit. Or you can talk about in different scenario. You can say that the happening of first event has 40% probability, the next has 35% probability, and third one is 25% probability. You can consider or think about this in any way. But the idea here is that, so whatever observation that is given to you, whether they are occurring with some particular pattern or not, we want to test that. And we have noted the value that is given to us observed under observed category, although you can use any name. I am using the name observed because it is very easy for you to understand this. Expected means the way that you want. Okay, so if I want that my first observation should hold 40% weightage of the whole data set, second observation will hold 35% weightage, and the third one is 25%. You know that the summation is coming as one, right? It can't be go to more than one, or it can't be more than 100%, right? So in any way you can think about. So we have this condition that the total of this thing should be equal to same. That means if I take the total of here 50 plus 30 plus 20, that should be 100, and it can be more than 100 also. But when I multiply this weightage with this observed value, the answer should be equal. That means for observed value, if it is coming as 200, then for the expected value should be also be coming 200. This is the main requirement, right? So now I want to test that whether the assumption that I assume that the first observation should hold 40% weightage, 35% weightage, and 25% weightage, that is valid or not. So I'm going to use a test that is called chi-square dot test. Chi-square, this is CHI chi-square dot test. And here I am first taking value that is observed, that is given to me. Then I am taking P is equal to expected divided by sum expected. Because in expected, what we have the values like this one, 0.40 into multiplied by something. So I want to convert into probabilities. Although you can directly put 0.40 here, 0.35, 0.25, or another ways you can divide by expected by the sum observed. So what we got here. So you can see here, although the variation of this thing, if I directly tell you the output will be this one. I think the idea is clear. If you multiply 40 with 100, you will get 0.40 with 100, you will get 40. 0.35 with 100, you will get 35. 0.25 with 100, you will get 25. The answer will be 100 under both sides. Yes or no? Right. So I want to test that whether the variation among these observations that is very significant or not. So here you will get p values less than greater than 0.05. So you can conclude that the variation among these observations, that means observed one and expected one, that is very little one. So we can conclude that the expectation, that means this observation fulfill my expectation. That is called goodness of it. So if there is a variation among this value, so you will have p value is less than 0.05. So it means I can say that whatever I expect from this data set, that is not fulfilled by this data. Okay, this is the main criteria that, and in most of time people use this test in literature. So I have kept one example here. So I got some message. Let me read it. Okay. So now coming, so this everything is able to understand the concept of chi-square and goodness of it, right? If someone has still any doubt, one can ask. Hello. Should I repeat again or should I proceed further? I want to know only this thing. Okay, now coming to the next topic, that is called test of independence. Let me tell you, how many of you have seen this type of 2x2 table? And I'm writing it here on here. Okay, so here you can see that purchase online. I'm putting it roughly for you to make it more easy for you to understand. So now you can see here that we have such type of problem which we have 2x2 table or 3x3 table. It can be any 10x10 also, but I'm starting with the 2x2, right? I want to see that whether and there's any relationship exists between purchasing, purchase, no purchase, online, offline. I want to make the I want to do some study that whether people wants to purchase online, wants to purchase online or offline, or they do not purchase item online and they prefer a no offline purchase. Hope the idea is clear. Should I repeat again my example? I have these 2x2 matrices in which I have one category of purchasing, non-purchasing. Okay, and other one is online and offline. So you can see that nowadays people prefer more purchase online. That's why we have highest frequency here. So it means these values show the frequency of people. They are distributed among these categories. So you can see that 70 plus 30, 100 of people, 100 persons are with me. And I have information regarding them that 40% or you can say 40 persons, they want to purchase item online and 10% people want to purchase item offline. And there are some persons they do not want to purchase online and they do not want to purchase offline also, right? Because it is a wish, someone wants to purchase things, someone do not want to purchase things, right? So we want to make an inference that whether purchasing has some relationship exists between offline, online, offline or not. So my null hypothesis that there is no relationship or no association between purchase and platform. So platform here means online, offline, right? And we are storing our data in the matrices. So I think you have covered matrices. If you have not covered, let me explain to you. Matrices means when you want to store your data in terms of matrices form in 2x2 matrices. So here you can see that I'm storing the value 40, 10, 30, 20. And first I have to store this value in concatenate function. Then how many rows I need? I need 2 rows. And I want to give the name of the columns. So the columns are given here as purchase, and although I have given the name as rows, here it is column name, and row names are given as online, offline. So after that, I will call the data variable in which I have stored my values in chi-square.test. So what type of output I have here? So from the output I got that p value is coming to be 0.049. So now this question is for you whether we are going to reject my null hypothesis, this one, or do not reject my null hypothesis. Tell me. Hello.
Reject now, sir,
Okay. Why, ma'am?
because it is less.
Okay. So if it
Five.
is 0.05 exactly equal to 0.05, then sorry. So approximately it is close to 0.05, right? Are you with me? So basically, in both cases, we are going to reject the null hypothesis, right? If it is going to come as 0.051, so we do not reject the null hypothesis. So it means that we can conclude that purchasing and platform, they are associated. Okay. So I will take questions now because we have 10 minutes left. So ANOVA I can't start because for the ANOVA I have to discuss a lot of things. So any questions from the audience, I will take questions. That is my preference. So anyone has any doubt till now? No. Basically rounding off in when we talk about, you can say, testing a hypothesis, right? So we want to see the 3-4 digit number. Okay, we can't go to 2 digit, we can't go to 1 digit after decimal. We prefer to go to 3 digit number after decimal. Then based upon that, we have to conclude. Okay, rounding off is not possible that we can convert this 0.049 to 0.05. Okay, so you have to go to 3 decimal after 3 digit after decimal, and then based upon that, you have to conclude. Hope you got my point. Anyone else? So
Sir,
if
is it
someone,
fine if I ask you a question, sir?
yes, ma'am, yes, ma'am.
Sir, if the number of data is little high, we have computed for a very lesser number of data.
Yeah,
If we
so-
have a very higher number, like hundreds of data, in that case, is it okay if we mention it as in a matrix form, or can we go for a CSV file import? And
Basically, the thing that means yesterday you have covered topic data frames, how to construct data frames, how to upload and download, sorry, upload and create Excel files, CSV files. Have you covered that?
I don't think we have covered exporting files inside, sir.
Okay, so basically, the thing is here, if I'm going to discuss about that data, that means if I'm going to discuss about very large data, that is not able for me to help you understand. I have done examples in real life. We take data from CSV only.
Okay.
Here, the example that I've kept, that is for only for small data, so that if you want to reproduce, you can easily reproduce.
Okay. Okay. Thank you, sir.
Okay. Any other question from the audience? I have kept my session so that you can try yourself also later.
Okay.
So, otherwise, some people will get bored to type observations, right?
I have one more question from my
Yes.
side.
Yes.
For the independence test of independence, should it always be a square matrix?
This one, ma'am.
Yes.
Yes, ma'am. Basically, okay. So let me help you more. So when we talk about this testing of independence or testing of association, right now. So although we start with 2x2, 3x3, sometimes we do not have observation in any cell. Then we merge that row into the previous one. In theoretically, the concept is there that if we have no observation in any particular cell, then we have to merge it. In that case, the number of rows and number of rows can be different. But we can, you can say some cases, it depends on the objective also. For some cases, for example, you can have 2 rows and 3 columns. Hello?
Yes, sir, I understand.
My God, that means I want to say that based upon the categories that we have in one variable. For example, here we have two categories, purchase and no purchase. If we have third category, based upon that, you have one more row, but we have only 2 categories, the second variable. Then it means we have 2x3 matrices or 3x2 matrices. It depends on the objective.
Okay. Okay. Thank you, sir.
Any question? Any further
Participants, you
question?
can feel free to switch on your mic and then ask questions if you have so. Or please feel free to type it in the chat box.
And also want to know your feedback, whether you are able to understand the concept, because some of students, they are very much new to this topic. So that's why I have kept it very simple for them. If I directly start with the coding part, you're not able to understand it. Hello.
Can we have access to these teaching materials?
Sorry.
Can we have access to these teaching materials?
Yeah, I will provide you this document that I've discussed with you today. So you
Okay,
can
sir.
try yourself.
Thank you very much.
Okay. Anything else?
Are there any more questions? Sir, we might not, it might be not related to the thing that you told, but we are always having a problem when we are trying to find out the mode of a given data in R. Is there any
Mode.
shortcuts to do that, sir? Yes. Mode.
Basically, yesterday, okay, there's another function we have to install. Text, and I think if I'm not wrong, DSC tools. Let me check whether I have kept it here. Actually, there was some confusion yesterday that regarding the session.
Because for mean and median, we have that inbuilt function where we can use
Summary,
PC.
from the summary also you can derive, but for mode, this is specific function. Let me show you.
Yes.
This function, I think, okay. You first have to install this library, des tools, then mode M capital should be, so the first letter should be capital.
Okay. Thank you, sir.
Okay. Any
This will
other,
help us a lot.
yeah. Any other query, any other question from the audience? And I also want to know that whether you're able to understand something new from my session or not. You just write down here on the chat box. Are you comfortable? My objective is to teach statistics to non-statistical background person. Okay. Thank you. Thank you, Ravi Shankar and Logan Nayak. So if there is no any further question, should we close the session or is there any question further?
Yes, sir. Is there any questions from the participant side? Okay. So if there are no questions, then we would like to thank the speaker a lot for patiently answering us with all the doubts. And we would like to thank participants also for posting their doubts in a very softer manner. Thank you so much for all for joining us in this session. We would like to break now and then resume the session 2 by 12:30. We would like the participant to join promptly during that time. Thank you so much. Thank you so much, sir.
Thank you.